Good afternoon, everyone, and thank you all for joining us for our October webinar series. Today, we have Marienna MacDonald. Marienna is a senior engineer and section head cybersecurity at the Canadian Nuclear Laboratories. If you haven't heard about the Canadian Nuclear Laboratories, the Canadian Nuclear Labs is Canada's leading nuclear science and technology organization, actively involved in industry-driven research and development. Marienna has 34 years of experience in nuclear power plant instrumentation and control systems. She has expertise in software development lifecycle for mission-critical software, developing work practices that meet international standards for requirement definition, system design, change control, configuration management, software release and testing. Her quality assurance experience has extended to establishing and managing the QA program for Nuclear Research Lab, as well as conducting the safety analysis of replacement industrial equipment to IEC 61508, IEC 6153 standards. In recent years, she has focused on developing best practices for industrial system owners to meet cybersecurity standards based on a wide range of national and international standards and guidance, including CSA, NIST, IEC, EPRI, and IAEA, and addressing topics such as governance, roles and responsibilities, secure coding practices and supply chain. When not doing technical work, Marienna is responsible for growing the cybersecurity team and supporting new staff in a fast-paced and technically demanding environment where innovative research is balanced with growing a commercially competitive cybersecurity business. Marienna's presentation, as you can see, is titled Simulation-Enabled Research Training Exercises for Cybersecurity and Instrumentation and Controls. Marienna, the floor is yours, please.
Thank you, Awele. Happy to be here and participate in Cybersecurity Month. And that building that you see in the image is our Cyber Center in Fredericton. We occupy an office in that building. So today I will be presenting CNL simulation capabilities and how these capabilities are used to support our research. The agenda for today's presentation, I'll talk briefly about the drivers for the work that we do. I'll describe our cyber range, which is a key simulation platform for supporting our research, and we'll look at some applications to show how these simulation capabilities have been applied. Before I get too far, I want to talk about the term OT. So typically when we think about cybersecurity and protecting cybersecurity or protecting industrial or business systems, we think of IT we think of cybersecurity in the context of IT systems typically. IT systems being, enterprise business systems, and we want to protect information, intellectual property, financial data, health data, those kinds of things. And we often are not thinking about our industrial systems, which we use the term operational technology or OT as parallel to IT. So those industrial systems are operating in real time, 24/7. So we can't simply, turn them off to load up a patch. So the research that CNL performs is in the context of these OT systems specifically. And what are the drivers? So when cyber attacks became a thing, I guess around the early 80s, we typically thought of them as being a threat to our business systems. And it wasn't until Stuxnet occurred in 2010, which was an industrial system, an air gap system, it wasn't on a network, that it was a real wake-up call because there was now concern that maybe our industrial systems that we thought were, impervious to cyber attack, maybe in fact they are vulnerable. At the end of last year, the Canadian Centre for Cybersecurity put out a publication where they assessed that the wide availability of free, stolen, commercial, and criminal cyber capabilities and services is likely lowering the threshold of sophistication necessary to target and sabotage OT. So essentially what they're saying is what once required a nation state capabilities is now becoming available to less sophisticated actors. And this was evidenced by the attacks that occurred in 2020, which ranked on the lower scales of sophistication, and yet they interrupted operations for those facilities anywhere from 2 days to 6 months. Many of these attacks were found to have occurred many months. You know, the attacker actually penetrated the systems many months before they were detected, and the targeted organization was not well prepared to respond to that attack. So part of our research and development efforts are to compress that detection time and to improve the response capabilities. So what's our mission and our focus areas? So our research is intended to benefit the Canadian public to advance cybersecurity risk reduction and resilience for OT environments employed in nuclear, but also other critical infrastructure. We have a couple of focus areas, one being training. There's certainly no shortage of IT cybersecurity training. There's less available in terms of OT cybersecurity training, and there's even less that sort of targets specific roles. So for example, if you have an engineer on a plant floor, what kind of cybersecurity awareness should they have versus say someone in procurement who's responsible for buying some of these OT devices that have software? What do they need to know, and what perhaps terms and conditions need to be in place for acquiring these assets that take cybersecurity risks into account? So training is a focus area. Also exercises. I'll be talking quite a bit about our incident response exercises that we conduct. We do research in assessments. So those assessments could be supply chain assessments, assessing suppliers, assessing products supplied by those suppliers, doing maturity model assessments, assessing an organization's level of maturity and capability in cybersecurity. And that would extend also to compliance assessments to particular standards, because organizations actually do have requirements to meet standards when it comes to cybersecurity protections. We also have a focus area in technology development. So for example, we've developed some custom application that is essentially an intrusion detection device for OT networks. The traffic on OT networks is different from from the traffic that's flowing in IT networks, and this anomaly detector is tailored for that. And in all of this work, our cyber range supports the simulation capabilities that allows us to conduct this evidence-based research. So let me talk a little bit more about our cyber range. Here's a photo. It's a state-of-the-art, safe, secure, and realistic platform. It not only provides a technology platform, but it requires documented operational procedures and processes that are also representative of what you would have in a plant. And this creates the realism that we want, so that we face the same challenges a plant would face in terms of how do we manage change to the facility, how do we manage passwords, how do we manage remote access, those kinds of elements. It implements representative systems that one would find in a plant, from shutdown systems and control systems to IT systems. And we try to have a balance between network systems and isolated systems as well, but all connected to the plant simulation. It's also safe and secure. So for example, we don't have high temperatures, high pressures in the loop. So if we have a device that fails among our equipment, it doesn't put anyone at risk. It's not a safety consequence. And that's something that I should have mentioned earlier when I was distinguishing OT from IT. OT assets, that the important distinction is, if they should fail, they can often have a safety impact or an environmental impact. Versus an IT asset, if it fails, it's typically inconvenient, it might interfere with scheduling, but generally there's not a safety impact. We can also control the security of our cyber range. We can close it down or open it up, depending on what kind of architecture we need for a particular experiment. And it's a standalone environment, so it's not connected to our corporate network, because we want to be able to introduce malware to it to conduct our experiments. We don't want to put our corporate network at risk, and nor do we want interference from our corporate network. So in terms of the simulation capabilities, it offers a low fidelity simulation of boiler pressure control that's implemented in a MATLAB model. and has also a boiler level control simulated through actual hardware. So we actually have pumps, real valves, programmable logic controllers, PLCs, smart sensors. And again, it's creating that realistic environment and real equipment that we can interact with. The cyber assets are grouped and separated into zones with boundary protection between those zones, and then they're arranged in layers of increasing security. So, for example, we'll have safety systems in level 1, which is behind the most levels of security. Then we'll have in the middle layers process control and human machine interfaces. And the upper layers where there's the least security is our IT systems. And among our IT equipment, we have workstations and servers, domain controllers, email servers, and so on, repository. And again, in a real plant, they too have these business systems, and they are very often the gateway for attack. So again, we're trying to create that realistic platform for our research. This is showing the screens belonging to a full scope Candu 6 simulator. So these are actual touch screens. And again, this is an enabler for doing our research. We can bring in operators who can experience simulation of a power plant. And in fact, we can actually interface to the simulator actual controllers. We can take a controller and replace the gauge on that screen with the gauge from that actual controller. So we can connect that controller, we can introduce malware to the controller, and then we can have an operator experience what operational conditions change when now you have a compromised device involved in that in the behavior of the plant. So again, it's just another enabler to help with our research. So another aspect of our simulated environment is our physical space. We have 3 security operations centers. The one on the right integrates IT and OT security monitoring. The one to the left of that is a dedicated OT security monitoring room. And then up in the top left corner is a CAS central alarm station. So that's where we bring in physical security monitoring. We have cameras, we have devices on doors so that we can tell if a door is open or locked, if it's open or closed. So again, these are also controls that come in to protect OT systems. It's not just technology, it's not just processes, it's also physical barriers. So again, we are trying to create those, offer those elements to enrich the research that we can conduct in the incident response exercises that we can host. And this, the schematic is simply showing that we're monitoring log data from our assets that is communicated via regular network traffic up through boundary protection to a theme. And we also have span traffic as well that is duplicating that network traffic and undergoes network analysis and intrusion detection as well. We also have our anomaly detection system that I mentioned earlier that is monitoring our OT network, so we can train it for what normal behavior looks like, and so that is able to detect anomalies. And we also have a portable media scanning kiosk so that we're not plugging in USB sticks directly into the cyber range without them first being scanned for viruses. And likewise, after it's unplugged, we scan again to make sure we haven't introduced malware to the device. Speaking a little bit more about the physical layout. So I'd mentioned the incident response exercises that we conduct. So OT organizations are required to have a cybersecurity plan. In that plan, they're required to have a incident response plan, and they're required to practice that plan. So again, we are bringing in organizations so that they can practice incident response in a more realistic environment. Part of that requires that you have separation between the individuals performing the various roles. For example, you might have an operator occupying the control room, a security operations center occupying their room. When they're in their home environment, the security operations center is likely off in an admin building. The operator's in his control room. You'd have an engineer working out on the plant floor, perhaps. You'd have physical security occupying their space in a separate building, likely. And by having these dedicated separate rooms, we can create that isolation, because when you're responding to an incident, you have to think about, who do I need to contact? How do I contact that individual? The Security Operations Center might be witnessing alerts coming in, but he doesn't have any associated sounds or indicators necessarily that maybe there is something going on the plant floor coinciding with the alerts that he is seeing. So this sort of tilted view of the floor plan shows that we actually have glass walls to sort of allow light into the office space. But when we conduct these exercises, we pulled blinds down to create that isolation. And then we also have evaluators who are able to observe the exercise, and we can put them in a training area. We feed in audio and visual feeds without them actually interfering with the play of the exercise. So it's a purpose-built space that has proven to be, really effective at creating that realistic environment to allow players to really exercise in a more authentic way the exercise that they're doing. So some of the applications. So I've spoken about these incident response exercise, and given that it's kind of we follow a crawl, walk, run model, our first exercise was a tabletop. And while we didn't use the cyber range directly in this case, it certainly did inform the nature of the attack that we had going on for that particular exercise. And that attack involved malware being introduced to the IT network via phishing email, which then spread to the OT network. And at a specific time and date in the exercise, the malware encrypted and compromised some systems. So it was a really rich learning environment. These exercises test command and control. Do folks occupying these roles know what they need to do, who they need to contact, when they need to contact those individuals? They challenge operational decision-making. What steps should be taken to assess what other systems might be impacted by my cyber attack? Is there an adjacent system? Is there another network system nearby? Could there be an impact from this ransomware? Third-party resources. So it could be that if an organization were to suffer a ransom attack, there might be very skilled third-party organizations that can be really helpful. But then I think you need to have those agreements in place, because when you need them now, you need them urgently. And so having agreements in place allows you to expedite those relationships and get the help you need when you need it. So by practicing these incident response exercises, you come to the realization, oh yeah, I didn't consider that. Maybe I need to make sure I identify what third party I want to use and make sure those agreements are in place. Forensic handling, do I disconnect my machine that's compromised? Does that put any other system at risk? Does that compromise my ability to collect forensics later, which I might need to want to do? And baselines and backups. Is there any risk that my attacker has compromised those systems? Do I know, am I confident that those are in the state they should be in so that I can recover my machines when I need to? So this sort of illustrates the myriad of things that come up when, in the course of actually having the opportunity to practice these exercises, you begin you immerse yourself in the experience. It's intense, things are happening quickly, and you're faced with a lot of decisions, and it helps to reveal some of the challenges and opportunities, and you can identify, what does your incident response plan do well, but it also helps to identify where perhaps there are gaps and where improvements need to be made. So then we went from our tabletop exercise to a functional exercise. And in this case, we're actually using our cyber range equipment more actively by the players. So the particular objective in this exercise that we hosted last March was the player organization wanted an opportunity for engineering staff and security operations center staff to work more closely together so that they could better understand each other's roles, and also to learn about security monitoring of OT devices, how to define events to log, how to set up the alerts, how to prioritize those alerts, what actions to take when those alerts arise, and so on. And then for the actual exercise, it started out by the engineer having to perform an authorized work order where the individual had to go out on the plant floor, interface with equipment, perform the work order, and in the course of doing so, alerts were generated in the SOC. So as is their procedure, the SOC would reach out to the engineer and say, I'm seeing these alerts. I don't understand, you know, I'm investigating why they're here. Can you tell me? So the engineer responds by saying, I am doing authorized work, interfacing with particular piece of gear. Those alerts are normal. They are expected to be raised when I'm doing this work. And I'll be continuing this work for about an hour, and I'll let you know when I'm done. So there's this exchange. The SOC operator is confirming with the engineer that the alerts are as expected and everything's fine. The engineer completes that work, goes off and does something else. Sometime later during the exercise, probably 10 or 15 minutes in exercise time, the SOC gets more alerts. And again, he reaches back out to the engineer to confirm, are these normal? I thought you had finished the work. And the engineer responds, well, I did finish the work. Nothing is going on with that device that I am aware of. I will go back to the physical area where that device is located, make sure no one's doing work. I'll check with the control room, make sure there's nothing about the plant state that would account for the alerts, and I will investigate and report back. So this is how the exercise plays out. And then as the engineer is investigating and he's beginning to reach the conclusion that, you know, this behavior cannot be explained. He's observing network traffic that cannot be explained. At about that same time, we had the attacker is actually able to manipulate a controller, causing the pumps to surge and get very loud, our tank levels to oscillate. The SOC is getting more alerts. And so now he's faced with, you know, he has a plant upset, and their first course of action is to restore the plant to a stable, safe state. So that kind of puts the whole cyber attack situation or suspicion off to the side, and these other priorities take precedence. So having the exercise play out like that was really illuminating in terms of now you have sort of competing interests. You know, who takes authority? Does operations take authority? Does security personnel take authority? You know, who's making the decisions and so on. So it was these kinds of exercises, because we're able to sort of replicate more realism, so that they can actually practice performing real procedures very similar to what they would do in a real plant and go through the motions. It illuminates a lot of these sort of challenges that you might not otherwise foresee. And so it's a great tool for improving incident response plans and helping organizations be more prepared in their response. So we did another exercise last week, different kind of attack, different objectives. There was more focus on doing collecting forensics, but again, very illuminating. And then we're doing a very interesting exercise next May, which is a blended cyber-physical exercise. So in this case, we're going to a decommissioned facility, and we are going to have an attack on the physical security equipment. So it could be cameras, could be physical barriers like gates and or doorways. So compromising that OT gear, which will, the reason that gear is being attacked in an exercise environment is to allow the attackers to actually enter the site at the same time. So the attackers are disabling essentially those protections so that they can access the site. So it's another exercise which will also be very rich in the learning. And then in general, other possible simulations we look forward to are, there's talk by the electricity grid regulator that they want to kind of bolster the incident response practicing that goes on. So there might be possibilities for us to get a electricity grid simulator and to provide that capability. Similarly, oil and gas or water treatment, OT equipment, you know, there are a lot of similarities to those architectures, to how those systems are protected. So, you know, we look forward to kind of sharing what we've learned in the nuclear arena to these other industries. The IT SOC operators are also overloaded with vast amounts of information and alerts that they handle on a daily basis. But the OT environment is very different. So our simulation capabilities allow us to generate OT traffic and see, you maybe there are different tools, better suited tools for doing security monitoring of OT networks. We certainly try to leverage what's available in the IT market, but this is where it's a challenge because sometimes these devices are not so well suited, and our simulation environments allows us to actually test them out. There's also likewise, through the simulation-enabled cyber range, we can develop and demonstrate and assess novel techniques with regard to advanced analytics, machine learning, and digital twins. And digital twins are like virtual models of physical systems. So I think that rounds it up. I think I've given you a good sense of the kinds of facilities we have, the capabilities they offer in terms of simulation, and provided, I focused on the incident response to give you an idea of how creating that immersive environment does generate some very rich practical learnings for organizations. Any questions for anybody?
Thank you very much, Marienna, for the brilliant and detailed explanation about your work at the Canadian Nuclear Labs. I think it was very informative. We don't have any questions from the audience here, but I have one.
Okay.
Just my own question. I don't know if it makes any sense, but I'll ask the question anyway. What are the benefits and perhaps challenges of having let's say an IT-OT convergence?
Well, certainly the benefits are there's a lot of technology available, and we don't want to reinvent the wheel. We want to leverage it when we can. So that's certainly a benefit, and that there's no denying there is that convergence, but it also creates risk, as you know, particularly on the IT side. That's very often the gateway of attack. So when there is that convergence, when you don't have that isolation and separation, it could potentially create a pathway of attack. So this is why we need to better understand the capabilities of these different systems and leverage the best of each of them, but also be cautious and do a lot of testing to make sure we are confident that we have the security levels that we need. And there are different security. There's certainly a graded approach that is taken in the nuclear industry. Because there are finite resources, and we want to make sure that we are applying those resources where we can get the best bang for the buck. So I don't know if that answers your question. We are trying to protect all of our systems. We're trying to perform assessments so that we understand where the vulnerabilities lie, and those things that have the greatest potential of safety impacts, we want to wrap around with the most protections. And if we can, we'll leverage IT, but we certainly have to do a lot of analysis to make sure that that's defensible.
Okay, thanks so much for the response. I think that's it. That's it for me. Thank you once again for speaking, and we really appreciate your time.
My pleasure.
And for our guests, we hope to see you guys again on the 14th. That's our next webinar.
Okay.
All right. Bye. Have a great day.
Thank you. Bye now.
Yes.